Okay, so it's day 82 of 100 Days of ML. And I'm back with paper a week. So what I'll do is go ahead and get this paper uploaded onto my iPad. I'm going to start with maybe the introduction and get an idea of like what the paper is about. I'll go over a summary and introduce the paper. And then what I'll do is update the paper a week repository with the annotated papers which are currently existing on my iPad. And finally, if I have time, I'll probably read Ishan Misra's and Young Kuhn's blog post on unsupervised learning. Currently watching a lecture, what am I saying? Podcast with Ishan Misra on Lex Friedman about self-supervised deep learning and computer vision. It's pretty interesting so far. I want to see and figure out like who Ishan Misra is for myself and kind of read his work. So I do want to check out his blog post. So first, I'm going to go ahead and get the paper downloaded. I have this uploaded to my iPad. I'm waiting for it to load. Till then, I'm just going to start reading here. It's called A Study in Rashman. Okay, just finished reading the introduction. I knew like I knew I heard Rashomon curves before, and I think after reading the abstract, I know where I recognize them from. And so basically, it's this process of kind of comparing the different models for a single problem. And what we do is plot these Rashomon curves, elbow curves, which allows us to determine, I guess, how the model is learning. And especially if it's a model is like this, like it's a straight elbow, there's no real curve, just means that, you know, it's a perfect model. Whereas if there's a curve there, it's learning properly. Stuff like that. I think I used it in statistical analysis before, but I still need to learn a lot more about it. I just had the basic concept of it in my head. And so this paper is going to introduce something called the Rashomon ratio, which is a new measure to determine the ratio of volume of the set of accurate models to the volume of the hypothesis space. It's just a way to relate similar yet accurate models for the same problem. And this paper is, like, I guess, a continuation of Leo Bremen's work, and it uses the fact that, you know, Leo Bremen talks about how there's multiple models for a single solution, and they can all have somewhat similar performance depending on what model you're using. So this paper tries to determine how to analyze the different models for a single problem and how to compare them and pick out which one is the most, like, beneficial for the current task. So not just accuracy, I guess, but also other properties such as interpretability, fairness, and I have no idea what this is, but monotonicity, I guess. I don't know. Guess we'll find out. Okay, I'll go ahead and read the introduction and come back and summarize it. Okay, just finished up with the introduction. So in addition to just the gamma curve, which is going to be introduced at the end, I guess this paragraph just introduces the paper as a whole and the different aspects that the author is going to focus on trying to describe. And basically, yeah, it's this fact that, you know, there's multiple models for a single problem, and we're trying to figure out how to correlate and distinguish the different models and try to pick out which model would be the best for a particular task. And so we do this by creating this ratio called the Rashomon ratio, which compares the volume. So it compares the Rashomon volume to the volume of the hypothesis space. And this setup will be explained throughout the paper. That's pretty much what the paper is about. And I think that's pretty much it, what the introduction was trying to say. It does set up a little more descriptions of what the Rashomon set could include. For example, the authors defined the Rashomon set as a set with all similar but yet accurately producing machine learning models. So it's a very important computation to do if you're comparing different machine learning models. For example, let's say you're approaching a task for classifying objects in a single image, and you don't know whether to use AlexNet or ResNet or any of the several thousand CNN models that currently exist, in addition to other classifiers like SVM and database models, right? So if you want to try to compute some sort of metric to compare all of these models based on the different properties and the accuracies that they produce, in addition to the interpretability and fairness and all of these other properties that are important for a model to take into consideration. This would be the metric to compute. And so he's going to define the Rashomon volume, which is important for computing the Rashomon ratio. And then we're going to set up what Rashomon set is, and I guess just understand a little more about what the Rashomon sets are. Because essentially it's going to come to creating this gamma-shaped Rashomon curve, which apparently is similar for a bunch of the data sets. So this constant factor makes it available for any model. And then finally, I guess, just conclusion and figure out the application of this. Okay, so what I'm going to do now is go ahead and update paper a week. Got to get my papers uploaded. So there's 2 so far. What I'm going to do is export it from my iPad to my computer. And what I think I'll do is clone this into my local repository and set it up in such a way that I have 3 folders, one for data science, one for machine learning, and I believe the other one is for deep learning. Let's see how this, so there's data science, ML, and yeah, I guess it's just neural networks and deep learning. So I'll make it into these different categories and upload my papers. So this is an example of how like I take annotations, usually just highlights and just a little bit of snippets. I'm generally a person who tends to learn visually, so creating like diagrams like this is very important from my understanding. Okay, let me get the other one as well. Okay, so I need to upload these into a file and then... So I do have the repository locally existing on my computer, so what I'll do is just upload the papers here. Okay, so I think these are the ones that are unannotated, so I'm going to go ahead and delete them. And I need to upload the downloaded ones. Okay. Let me go back here. All right, that should be updated, and I'll go ahead and... So I think I have some time. Yeah, so what I'll go ahead and do is check out Ishan Misra's and Jan Koon's blog post. This is this one. What is this? Is this a book? Nothing might beat this. Essentially, I mean, Ishan is on Lex Friedman's podcast, and Lex was talking about like Ishan's one of Ishan's blog posts about self-supervised learning. Oh yeah, it is this one. It's about the smart dark matter. Seems like a fairly short read. You check out what this is, if this is actually written by them. Okay, I don't think this article is written by them. It seems to be like some sort of summary. What the heck? How do I find this? It is this article. Here we go. I think this is it. Okay. I wonder if I could download this as like a PDF or something. Because then I could take annotate it on my iPad, but I don't think I can. Okay, what I'll do is most likely continue reading that article tomorrow. In 2 days, I have a final, so I'm going to take things lightly for the next two-ish days. So I'll continue with for a week, or else I guess I'll just start with the self-supervised learning article. I didn't know he was a chief scientist at AI. I mean, chief scientist at Facebook, vice president and chief AI scientist. I mean, this guy is hella popular in Vision. Pretty much created CNNs, I believe, or was it SVMs? I forget, but major contributions to the field of vision. Yeah. What is it called? Self-supervised learning. The dark matter intelligence. I should probably hyperlink this. Okay, so I think that concludes everything for today. Got the goal set up for tomorrow. So that's pretty much it for today then. I'll be back tomorrow.